Hello everyone. We're going to discuss about Mercury Manometer today. How a Mercury Manometer works, what is its function, and the factors that might affect Mercury Manometer. The height, actually, the height of the liquid in the Mercury Manometer. What are the factors that affect them? So let us start with the diagram of a Mercury Manometer, and then we will move on to the functions. So, if you go through your book, you will find the diagram there also. Kono diagram ache. You can see the diagram from there. Alright, so this is the diagram of a manometer, right? Now the manometer, its main function is to measure gas pressure. How much is the pressure from the gas supply of a cylinder or of a container, whatever you say, but it measures the gas pressure of a particular container, okay? Now, in my diagram, it might look like the thickness of the tube on both the sides are different. Like this one is a bit more thicker, this one is a bit thinner. But this is not the actual case. In the actual diagram, you will find that the thickness is the same on both the sides of the tube. Both sides will have the same thickness, right? So what happens initially is we are using mercury as the liquid inside this tube. So this tube is filled with mercury, U-shaped glass tube. This is what we call a U-shaped glass tube. So initially we put mercury inside it, and then we keep both the ends open. So you see, when you keep both the ends open, atmospheric pressure is acting from this side, atmospheric pressure is also acting from this side. As a result, the liquid is at the same level from both the sides. Both the sides, the liquid is settled at 40 centimeter. The center line, this may be assumed as a scale, so it's leveled in centimeter. So you see, the liquid is at the same level on both sides. Why? Because the pressure exerted on the liquid from this side and the pressure exerted on the liquid from this side is same, right? If you press the liquid by equal pressure from both the sides, eventually the liquid settle down at a common height, at single height and settle down holder, right? Okay, now we have to measure the pressure due to a certain gas supply. J, how much does that pressure come? And how do we do that? Let's see that first. So let me just erase this part. Okay, so what we do is we connect this side to a container or to a gas supply from where we are having a gas supply pressure. Okay, and let's say that pressure due to the gas supply is uh, let's say P1. Okay, uh, from here, from this side, we know atmosphere is exerting a pressure which is P0. Okay, and this side gas is applying a pressure. Initially, let us just assume this fact that the pressure due to the gas supply is greater than the atmospheric pressure. It's larger than the atmospheric pressure. So what will we observe here? We will see the pressure due to the gas supply, since it's larger, the liquid on the left hand side, this side, the liquid, it will go down. And the liquid over here, this will rise up, because this side the pressure exerted is more. The pressure due to the gas is more, so the liquid is supposed to go down. So if we just draw it here, let's assume the liquid was at the 40 centimeter mark first. So let's mark this point A and let's mark this point B. So initially the liquid was at the level A and B. Now when you have applied the gas supply, this extra pressure, the P1 pressure, what we will see is the liquid on the left hand side is coming downwards. It has come here. Why? Because the pressure due to the gas supply is larger than the atmospheric pressure. So at this point there won't be any liquid over here. There is nothing, right? So the liquid level has come down to a new value which is 20 centimeter. Let's mark this point C. And also you will see the liquid at B, this also will rise up. Where will it go? The new position of this liquid will be at 60 centimeter, because this has gone down by 20, this will go up by 20. So the new position of the liquid over here will be at 60 centimeter. So ekhane there won't be any liquid at B anymore. The liquid level rises up to a new position and let's name that position say D. Okay, so I guess so far it's clear to everyone that the liquid was initially at the same level at 40 centimeter, because from both the sides atmospheric pressure was acting. But now we have provided the gas and we are saying the pressure due to the gas supply is larger than the pressure due to the atmosphere. So it should be P0, it shouldn't be P2, it should be P0. So P0, the pressure due to the gas supply is larger than the atmospheric pressure. As a result, the liquid has come down to C, and this side the liquid has gone up to D. Now our problem is we have to find out how much is this pressure. এই P1 টা কত? গ্যাস সাপ্লাই এখান থেকে যে প্রেসারটা দিচ্ছে on the liquid, how much is the pressure here? এই P1 প্রেসারটা কত? Okay, so how do we find that? Now to find that, we have to go to another concept that we have already studied, that in liquid, if you measure pressure in a liquid along the same height, so this is point A, point B, this is point C, point D, we know the pressure at A should be equal to pressure at B, and pressure at C should be equal to pressure at D. That is, along the same height in liquid, the pressure remains the same. So any point along the same height, the pressure will be the same. Using that concept, what we do is we will draw a line here from C, which is at 20 centimeter mark. We will draw a line on the other side of the tube, and let's mark this point as E. Now listen to this carefully. Point C and E, they are at the same height, that is at 20 centimeter height, right? And we just discussed that if you are measuring the pressure along the same height in a liquid, the pressure will be the same because they are at the same height. So from that fact, we can assume the pressure at C and the pressure at E should be equal. Why? Because they are along the same height. So concept ki holo that if you go inside a liquid and measure the pressure at the same depth or the same height, along that line the pressure will be the same at all points because the height is same. The same concept is used here. We can't find the pressure at C directly. We have to find this pressure, but we can't find it directly. So what we do is we draw a line along the same depth at the other side of the tube and mark it point E. Since they are at the same height, the pressure is equal at E and C. Now if we can find the pressure at E, this should also give us the pressure at C since they are equal. Now how do we find the pressure at E? Ekটু ভালো করে, we will focus on that, right? Now the pressure at E, who is exerting the pressure at E? Let's just find that first. So at E, atmosphere is exerting a pressure from the top, right? So let's just write it somewhere. Pressure at E. Who is exerting the pressure? From the top, atmosphere is exerting a pressure. Plus there is another pressure. Who? The liquid column from D to E. This liquid column is also exerting a pressure. We know liquids, when they go to a certain height, they start exerting pressure, right? So from D to E, the liquid also exerts a pressure at E. So we can write the pressure is also due to the liquid column. Pressure due to liquid column DE. D to E, the liquid column is exerting also a pressure. So if we write it down in an equation now, how does that come? Let's see that first. So I'll just write it down here in short. Pressure at E is equals to atmospheric pressure plus, what did we write? The pressure due to liquid column DE. Now how do we find the pressure due to liquid column DE? We use the formula H rho G, right? So P naught we know is the atmospheric pressure, no problem in finding that. What is H here? H is the height. Which height? From D to E. D to E, what is the height? D is at 60 centimeter mark, E is at 20 centimeter mark. So the height should be 60 minus 20, which is 40 centimeter. So H is 40 centimeter, which means 0.4 meter. What is the density of the liquid? We know the density of mercury into 10, and the value of P naught we already know is 100,000 Pascal. Plus if you find the value of this one, this entire solution here, you add them up, you find the pressure at E. So once you find the pressure at E, sorry, let me just zoom it a bit. Once you find the pressure at E from our equation, which we have already written, we know pressure at E and pressure at C are equal. So once you have found the pressure at E, this gives you the same pressure at C.